Good morning, class. Now we have with us Miss Ramya.D from third year CZBT, and she is going to present her lecture talk on bioleaching from paper 5, Genetic Engineering and Environmental Biotechnology. All the best, Ramya.
Thank you.
Over to you, Ramya.
Okay, ma'am. Hello everyone. I am Ramya from CZBT third year. Today I am going to present a seminar on bioleaching. Before going straight away to our topic, let me briefly introduce how we are going to extract a mineral or a metal from their ores. There are varieties of physical and chemical metallurgical operations which are employed. Then, what are ores? Ores are the chemical compounds of different metals occurring in nature. In simple words, metallurgical operations. Then what is metallurgy? It is a branch of engineering. It is mainly concerned with extracting metals from their ore to make a refined alloy. Our bioleaching, it's a conventional method over operations. As no longer holds good, research for the alternative method has begun. Then they realized the role of microorganisms, that is bacteria, lichens, and all the microorganisms, and they put the use for their metal extraction even from the low grade ores. The application of microbes in the metallurgical operations has gained a tremendous impact, and a new interdisciplinary subject has emerged, that is biometallurgy. Our bioleaching comes under this biometallurgy. This technology has many advantages over the conventional technology, that is the biometallurgy. It is very simple, safe, and environmental friendly technology. It is cost effective, it is less energy demanding. Next. Akanksha, next slide please. These are the contents which are covered in this topic. Definition of bioleaching, microorganisms used in bioleaching, chemistry of bioleaching. There are types, examples. Examples goes like copper leaching, uranium leaching, gold and silver leaching, and silica leaching. Next slide. Now, let us go through bioleaching definition. What is bioleaching? In simple words, bioleaching is a process by which metals are dissolved from their ore-bearing rocks using microorganisms. Next. Then microorganisms has to involved in bioleaching. As bioleaching, bio means the living organisms we are involving in leaching process. So microorganisms should be used here. They are most commonly used microorganisms in bioleaching are Thiobacillus thiooxidans, Thiobacillus peroxidans. Other microorganisms also used. They are Bacillus licheniformis, Bacillus luteus, Bacillus megaspirillum, and Bacillus polymaxum, and ferredoxin, Pseudomonas fluorescens, etc. are used here. Next slide. Chemistry is involved in bioleaching. As the metallurgy is an engineering branch, the chemistry has to be involved in bioleaching process also. So Thiobacillus thiooxidans and Thiobacillus peroxidans have always been found to be present on the leaching dump, where we are extracting ore. The leaching dump is present there. These two microorganisms should be found there. The species of Thiobacillus is most extensively studied are gram-negative bacteria. They derive energy from oxidation of Fe2+. The reaction mechanisms are of two types, that is direct bacterial leaching and indirect bacterial leaching. Next. In direct bacterial leaching, this is a process where the physical contact exists between the bacteria and ore from which we are extracting our minerals, and the oxidation of minerals takes place through these enzymatic catalyzed steps. Example, pyrite is oxidized to ferric sulfate. The reaction is as follows. Next slide. And Coming to indirect bacterial leaching, in this process, the microbes are not in directly contact with the minerals, but the leaching agents are produced by these microbes, which then oxidized the ore in the oxidation pool. Next slide. Then there are many types. As we are going only three types here. There are three commercial processes used in the bioleaching. Those are slope leaching, heap leaching, and in situ leaching. Next. Coming to slope leaching, here the ores are first grounded to their fine pieces and then dumped into the large leaching dump. Water containing inoculum of Thiobacillus is continuously sprinkled over the ore. Water is collected from the bottom and used to extract a mineral and the generate bacteria in an oxidation pond. Heap leaching, here the ore is dumped into the large heaps called leach heaps. The water containing inoculum of Thiobacillus is continuously sprinkled over. The water collecting from the bottom and used to extract a metal and generate bacteria in an oxidation pool. Same as slope bleaching. Example for heap bleaching is gold heap bleaching, where the raw materials are finally get powdered and it is dumped into the ore heap bleaching dump, and it is drained the golden liquid, that is the pregnant solution of heap bleaching. It is the gold is recovered as the leaching process and it recycles. Water is dumped back into the ore heap. Next, heap leaching. This is a copper leaching. Copper, it's a good example for heap leaching and also in situ leaching. So low grade copper ore, that is one of the ore is extracted and here it is dumped into the heap leaching process. The bacterial solutions of salt water and hydrochloric acid, it maintains the pH. It has been sprinkled over and it is refined, settled, and the electrowinning copper electrophoresis has taken place here, and it is getting regenerated. The water is dumped back to the heap leaching process. Next. In situ leaching, in this process, the ore remains in its original position in earth. It is different from heap and slope leaching. It is a process where ore is remains in its position, but the surface blasting of earth is done here to increase the permeability of water. As I told you before, the water is sprinkled on the bacterium inoculum. Here, as we are surface blasting the earth, it increases the permeability of water which we are sprinkling over the water containing Thiobacillus is pumped through the drilling passage to the ore. Acidic water seeps through the rock and collects at the bottom. Next. The water is which is collected at the bottom, again it is pumped from the bottom. The mineral is extracted. The interest what the minerals we are extracting, and the water is reused after the generation of bacteria. Next. Example, copper leaching. Ores of copper from which the copper is recovered are, there are mainly three ores. There is chalcocite, chalcopyrite, and covellite. Next. Copper leaching is operated as simple heap leaching and in situ leaching, as I told you before. And here dilute sulfuric acid is percolated down through the pile, which maintains the pH. Liquid coming out of the bottom of the pile reaches in the mineral. Liquid is collected and transported to the precipitation plant. Metal is precipitated and it is purified. The metal is extracted. Next. The reactions are involved here are chalcocite is oxidized to soluble form of copper. The reaction goes like this. Therefore, chemical reactions occurs as follows. Copper is removed. Fe plus is transferred to the oxidation pond. Next. Fe3 plus ions produced in an oxidation pond of the ore, it is pumped back to the pile. Sulfuric acid is added to maintain the pH. Next. This is copper recovery process using biomining technology. Dump to low grade of sulfide copper ore is being dumped to the heap leaching process. Then leaching solution is being solvent extraction or electromining of the copper takes place using copper cathodes. Here sulfuric acid is added to maintain the pH and cultivation inoculum of bacteria has been sprinkled over the heap leaching process. Next. Uranium. As we know, uranium is a nuclear reactive material. Uranium 235. It is been extracted in a nuclear power plant. When it is insoluble tetravalent uranium, it is oxidized with the hot sulfuric acid solution to make a hexavalent uranium sulfate. As we know that their chemical requisite and the reaction has to take place, so the pH and temperature has to be maintained. Here the pH required for the reaction is 1.5 to 3.5. The temperature required is around 35 degrees Celsius. The following reaction takes place, that is uranium plus iron sulfate is reacted to give some products as follows. Next. Uranium leaching is an indirect process where thiobacillus peroxidant are involved in the uranium extraction. They do not directly attack on the ore but on the iron oxidant. Then it is dumped into the oxidation pond. The pyrite reaction is used for the initial production of Fe+. The reaction is goes follows. Next. Gold and silver leaching. The gold and silver the leaching are done by the refractory process. We know that it is a bacterial leaching of refractory process metal. To enhance the gold and silver recovery is one of the promising application nowadays. So gold is obtained through a bioleaching of arsenopyrite or pyrite, or silver is also obtained by the bioleaching of arsenopyrite, but it is more readily solubilized than the gold. So during microbial leaching of iron sulfide. Next. Silica leaching. The ores of silicas are magnesite, bauxite, dolomite, basalt. Mohantoy isolated Bacillus licheniforms from magnesite ore deposit in the year 1990. Later, it was shown to be associated with the bioleaching. Concomitant mineralizes. It is a natural phenomena where mineralizes of the ores takes place and silica uptaken by the bacteria. Next. Next slide. Now moving on to advantages of bioleaching. This bioleaching is simple, inexpensive recovery of material from the low grade ore. As in metallurgical process, the rock leaching rock should be bigger, but here we can recover a metal from the ore from the low grade ore itself. Then to extract, refines and expensive metals, which is not possible by the other chemical process, using bioleaching can be extracted. It's employed for collecting metals from waste and drainages also. Then no poisonous sulfide dioxide is emitted here as in smelters in metallurgical process. Then no need for high pressure and temperature. Ideal for low grade sulfide ores also. It is environmental friendly process, that is eco-friendly. It is ideally suitable for the developing countries like India. Next slide. There are many disadvantages of bioleaching too. Those are the heat created from the dissolving process can kill the bacteria. As we're using microorganisms in bioleaching, the heat created by this process, they can kill the bacteria. And it is a very time-consuming process. It may take 6 to 24 months or longer than that too. It is low yield of mineral, requires a large open area for the treatment. As it requires open area for the treatment, there is high risk of contamination to our leaching process. Next. These are the references I have referred. Thank you.
Okay, good job, Miss Ramya. Akanksha, can we go to the next slide?
Thank you.
Further, Ramya, you will be notified shortly about your seminar presentation marks based on your presentation, voice modulation, and depth of the content. Okay.
Okay, ma'am.
And even we'll conduct shortly group discussion and interaction session. That time we'll also get further updating information related with the bioleaching. But really good presentation was really good. Okay, thank you for investing your valuable time. Thank you one and all.
Thank you for giving us opportunity, ma'am. Thank you so much.
You're welcome. Thank you. You deserve.